Here's the first lecture about Module 5, Objects and Classes. We'll talk more about these on Module 6 also. So here are the outcomes. As always, go back and when you're done with this module, make sure you understand these outcomes. Review. So an object, as we know, is a set of attributes and methods. A class is a design of an object, and an object is an instance of the class. So an object is the actual thing, the class is the design. We often use those words interchangeably, but there is a distinction. You can think of an object as a physical component. If you're modeling a complex physical system, you're modeling the solar system, the objects are pretty easily identified, the planets, the star, that kind of thing. You can think of an object as a device that performs a specific task in a complex system. So if you have a task that has many parts to it, then you can break that task up into maybe a series of tasks, and then each task is performed by an object. Or you can say, my system can perform 4 different major functions. Maybe each one of those becomes an object or a collection of objects. You can also think of it as a manager that then controls those objects. It's a little harder to think of the object as in a non-physical way, but you can think of them as service providers. Think of the math object in Java. The math object is a service provider. It's providing you access to all the different math functions that you might need to use. And the more abstract of all, you can think of it as a process. So if you need to do, say, collision detection, maybe you have an object that is a collision detector. That's its job. It's a process that performs that operation. The object-oriented paradigm views computation as interaction among objects, and the best way to understand that is to write a bunch of programs and watch how the objects interact. We'll have a little bit of discussion here about how objects relate to memory. Remember, when your Java program runs, it actually runs through something called the Java Virtual Machine, or JVM. And the JVM is the thing that handles all of the memory. If you remember, the main reason why object-oriented paradigm was put out there was for data encapsulation. So again, the idea is no one can touch my data. The cost of that is that you have less direct access to memory. In programming languages like C, you can point directly to memory locations. In object-oriented programming languages, you tend not to know where things are stored in memory. You tend not to be able to access memory locations directly. Instead, you reference them indirectly. And you do that with the object name. The object name, so when you create an object, you give it a name. Basically, that thing is supplied with what I'm going to call a handle for that object, and that handle is the thing that will point to the memory locations. And we'll do some examples in a minute that hopefully will clarify that statement. So each each object has memory devoted specifically to all of its attributes. Each class has memory reserved for the methods. And if you think about it, this makes sense. The attributes for each specific object are going to be unique. If we go back to the sheep-sheepdog example earlier in the semester, I've got 3 sheep. They have attributes, X location, Y location. The value for each of those are going to be different because the sheep are at different locations. So I need to have separate memory locations for the sheep attributes. However, the sheep all have the exact same methods, and it would be wasteful of memory to copy those methods down for every unique object that was created. So I don't need 3 copies of the methods just because I have 3 sheep. So instead, each class has memory reserved for its methods, and that one memory location that stores the procedures for the methods serves for all 3 sheep. When you declare an object, all it does is it reserves the space for the handle. It says, hey, in memory, it tells the Java Virtual Machine, somewhere in memory, reserve a space for the handle for the object, because someday I'm going to create an object. Once you create the object, then the Java Virtual Machine will reserve space for all the attributes, and it also sets the value for the handle. It says to the handle, okay, I stored this stuff over here. Objects can pass back and forth their handles, and that's how you can refer to objects. And this is used primarily for method input and output. So if you need to have as input to a method an object, what you're really doing is you're passing the handle in so that that method has access to that memory space. So let's go through some examples here. I've got some code on the left, and then I've got memory represented on the right, and we haven't executed any code yet, so the memory is blank. And then I declare 3 objects of the class foo. Object 1, object 2, object 3. So the memory space is set up. Hey, set up some space just for the handles for object 1, object 2, object 3. And yes, those are out of sequence. There's a reason for that. Now if you look, the class foo has 3 attributes, or at least 3 attributes that we're showing. Their integer values x, y, and z. So as soon as the line of code object 1 equals new foo is executed, remember new is the keyword whereby you know that an object is created. So I've created object 1. That means now in memory I need to reserve space for x, y, and z, and that's shown over here. And I need to have a handle for object 1 so it knows where x, y, and z are. And so that's shown with this arrow. Then I can say object1.x equals 42. Now you understand hopefully why that dot notation is there. Object1.x, well, by saying object1.x, what you're saying is not just any x value. It's the x value that's pointed to by the handle of object 1. So we're setting the value 42 inside that memory location for x. Now we create a second object. Object 2 equals new foo, and I know it's a new object because of the new keyword, and that means that I get to set up space for that x, y, z for the new object and the handle. And then I say object2.x equals 54. See, if you just said x equals 54, the Java virtual machine wouldn't know if you meant the x that belongs to object 1 or the x that belongs to object 2. So you tell it object2.x. Now here's the one that initially may surprise you, but after a while you get used to it. I'm going to say object 3 is equal to object 1. Now there's 2 ways that this could be interpreted. One is object 3 is a brand new object and it's a copy of object 1. That's not the way it's going to work. Object 3 and object 1, remember, those are both placeholders for handles. So when I say object 3 is equal to object 1, what I'm really saying is the handle for object 3 is the same as the handle for object 1, and object 3 and object 1 actually point to the same memory space now. So now when I say object 3.x equals 10, it puts the value of 10 in the x location for that memory space. It happens to be the same memory space that object 1 is pointing to. So I could have said object 1.x equals 10 or object 3.x equals 10, and the operations inside of memory would have been exactly the same. This is good to remember because sometimes you're thinking that you put a value into a particular object and maybe you're not getting a result that you expected. But if you walk through what's happening in memory, it can clarify that kind of confusion. So now on the next line of code, when I say, okay, let's print out what object1.x is, well, it's going to be 10, because remember, object 3 and object 1 pointed to the same memory space. So when I change the value of object 3.x to 10, that's the same memory space that object 1 is pointing to. So when I say print out object1.x, that memory space has the value of 10 in it. Now let's do something unusual. Object 2 is equal to object 1. Oh, okay. What did it do? It changed the handle for object 2 to object 1, and now everybody's pointing to the same memory space up here. Nobody's pointing to this memory space that used to be object 2. And the memory space that's no longer pointed to is gone. You can't access it anymore. Eventually, the Java virtual machine will delete it. The Java virtual machine has something called a garbage collector, and it goes through periodically, and it looks at what memory spaces can no longer be accessed and cleans them up and reallocates them as free so they can be used again. But there's no way to get that data back. Once you get rid of all of the references to that data, it's gone. Meanwhile, everybody's up here pointing to, everybody's up here pointing to what used to be object 1. Object 1, object 2, object 3, they're all pointing to the same memory space now. And then one more change, object 1 equals new foo. Well, we said new. New means create a new object. And since new means create a new object, that's what happened. And now that handle for object 1 points to that new memory space. So whenever you use the new keyword, if you set object 1 equals new foo, and you put some values in there, and then you say object 2 equals new foo, you don't have access to the old values anymore because you've literally created a new object. And now when you say object 1.x equals 52 or whatever, it'll be in this memory space down here. Now in my example, these object 2 and object 3 are still pointing to this memory space up here. But if they weren't, this memory space would also be gone. Okay, I'm going to pause here and then we'll continue with talking about relationships between the objects.